Welcome students, myself Aishwarya, Computer Faculty at Shakthi Residential PU College. Today I am going to summarize the chapter Problem Solving Methodology. So let us see what does this chapter deals with. Problem solving. What do you mean by problem solving? It is defined as the process of finding a solution for a complex problem in terms of simple operations that can be understood by a machine. In simple terms, problem solving means you are finding a solution for the given problem. That's all. And this problem solving process consists of some steps. The first step is problem definition, then problem analysis, algorithm development, coding, testing and debugging, and documentation and maintenance. So these are the steps involved in problem solving process. What do you mean by problem solving? It means you are finding a solution for the given problem, and this problem solving process consists of some steps. The steps are problem definition, analysis, algorithm development, coding, testing and debugging, and the last is documentation and maintenance. Now let us see each process. First one, problem definition. Here you are going to define the problem. When you define the problem, you will know the necessary requirements that are needed. So you will specify the requirements. That is what problem definition deals with. After defining the problem, next step you go for analysis. So here you will analyze the problem. What does the analyzing means? First thing, input. You will get to know what type of data you have to work with. Input are the data given by you. So you will know what type of data you are giving, that is input. Next, output. Once you give the input, you will get back the result. That is called as output. Next, any additional requirements and constraints for the solution. So what are constraints? Constraints are nothing but they are the condition given by the user. So problem analysis, it deals with three requirements: input, output, and any other additional constraints or requirement. That's what problem analysis deals with. The third step is algorithm development. To know what is algorithm development, I have to explain you first what does an algorithm means. What do you mean by an algorithm? Algorithm is nothing but step-by-step procedure. Why? To solve a given problem. Algorithm are step-by-step instruction. Why? To solve a problem. That's what an algorithm means. Now let us see how to write an algorithm for a problem. Here you have to design an algorithm to find sum of two numbers. Now let's write an algorithm to find sum of two numbers. Let first number, let it be 10. I'm assigning the value to A. And the second number B, I'm assigning a value 5. So I have two numbers. I am assigning that values for the variables, that is A and B. Step 1. What is step 1? Start. For all the algorithms, you have to begin with start. Second step, you have to input A, B. It means you are inputting what you are using. Whatever the variable you use in the algorithm, that should be input in the second statement. So I am using only two variables, two numbers. So I am input A, B. That's what I have to write in the second step. In third step, it is mainly for the calculation part. Any calculation you have to mention it in the third step of algorithm. That is sum is equal to A plus B. Here what happens, it is value of A, that is 10, plus value of B, that is 5. You will get it as 15. This 15 value will be assigned to the variable called sum. So now sum will hold the value 15. In the fourth step, you have to output sum. It means you are printing sum. So print 15 will be done on the step 4. So step 4, you will get print 15. 15 number will be printed. That is output. Last step, it is stop. See, algorithm, it's a step by step. It begin with start, ended with stop. This is same for all the algorithm. The first step and last step, it is same. In the second step, you have to input whatever the variable you use. In the third step, you will perform the calculation. Any calculation will be performed here. Then you have to print that. Calculated part you will assign the variable to and you will print that part in the next step. And finally you will stop the algorithm. This is the way to write an algorithm, and the procedure is same for all the questions. You have to follow the instruction properly. First step you have to write start, and last step of course it is stop. In the second step you have to input whatever the variable you use. Third step is for calculation. Once the calculation part is done, you have to print the output. And finally you have to stop your algorithm. This is a way how to write an algorithm. Now let's see what are the advantages of an algorithm. It is flexible to write. Why it is flexible to write? Because here we are not using any programming language. See, it is independent of programming language because we use English-like statements. More than that, it is step by step. See, I have written the instruction step by step. As it is step by step instruction, it is executed in a period of time. And it is very easy to develop a program too. See, to write a program, first you have to draw algorithm. After algorithm, you have to draw something called as flowchart, which we will discuss now. And after that, finally, the program is developed. So these are the advantages of algorithm. First thing, it is very easy to write because we use simple English statement. We are not depending on any of the programming language. As it is executed step by step, you can finish it in a period of time. And it is very easy to develop too. It will help us to develop a program. These are the advantages of algorithm. Now you had seen what is an algorithm. I have told you in order to build a program, first you have to draw something called as algorithm. Then you have to create a flowchart. So now let's see what is a flowchart. The pictorial representation of algorithm is called as flowchart, and this is an example for flowchart. See, here I am swapping the value of two variables by using arithmetic operator. Swapping means I am interchanging the value of two variables. Suppose here I am giving value of A is equal to 5, value of B is equal to 2. So, after swapping, I want the values to be interchanged. A should have 2 and B should have 5. And here I am using arithmetic operators or arithmetic equations in order to do this. Initially, I am giving A is equal to A plus B. So, I'll get an answer 5 plus 2, that is 7. So, initially A will have the value 7 here. Then I'm giving B is equal to A minus B. So, B value will get 7 minus 2. See, I have changed the value of A here because now A is assigned the value 7. So, here it is 7 minus 2, A minus B. So, 7 minus 2, you will get the value as 5. So, here value of B is now 5 at the second step. Now, I am again giving A is equal to A minus B. So, what is the value of A here? Of course, 7. So, 7 minus 5. My answer will be 2. Now, you can see the value of A is 2 here and the value of B is 5. So, this is how I write an algorithm to interchange the two values. So, this is algorithm. See, initial step, it is start. I have to write start for the first step of an algorithm. In step 2, I have to read the value of the variables which I use. That is, I am using two numbers. I am reading the value of two variables. In step 3, I am performing this arithmetic equation in order to interchange the value, to swap the values. And in the final step, I am printing the value or I am outputting the value. That is, print the value of A and B. You can write output A comma B too. It's fine. Last step, I am writing stop. That means it's the end of algorithm. So this is an algorithm and this is a flowchart. And I am representing same algorithm in diagrammatic way. It is called as flowchart. See, for start, I have a symbol in flowchart. You have to use same symbols for each step. For first step, that is start, and even for the last step, you have to use oval shape to represent in flowchart. For start and stop, you have to use oval shape to represent the flowchart. And to input the value or to print or display the value, you have to use parallelogram. You have to use parallelogram, and here you are using rectangle for the calculation part. The same algorithm, it is represented in flowchart. This is how you will draw the flowchart by using an algorithm. So initially an algorithm should be written, that is a step-by-step instruction. After that you have to draw the flowchart, and after that only you are supposed to write a program. This is a procedure. I hope you are cleared with the concept of algorithm and flowchart. Now coming to the next step, that is involved in problem solving. So now algorithm development is done. Now we are in development of program. In order to write the program, first we need coding. What do you mean by coding? Process of writing program. In what? In any of the programming language. That is procedural or structured or object oriented. Any programming language you can write the coding part. That is, you have to write the program in that specified programming language. It is called as coding. Next is testing. What do you mean by testing? You are checking whether all the parts are working properly of your program as the users need. That is called as testing. Then it is debugging, the process of identifying errors or bugs and removing them. That process we call as debugging. So you have coding, testing and debugging in the development of program part. As I told you, debugging means we are identifying the errors and we are correcting them. Now let us see what are the types of errors. See, you have syntax error, logical error, runtime error and semantic error. So errors are 4 types: syntax, logical, runtime and semantic. Now let us see what each deals with. First one, syntax error. What do you mean by a syntax? Syntax is nothing. It is a set of rules that you have to use in the programming language. If you violate that syntax, then it is a syntax error. For example, now see this program, void main. You have opened the braces, int a comma b semicolon. You have cout, means you are printing. Enter the number, semicolon. Sin, you are reading the variables. Sin a b semicolon. Then cout a plus b colon, and you have closed in the braces. See, according to C++ program, every program must end with a semicolon. It's a rule. It's a syntax. So here you have given a colon. So that is why this is a syntax error. Because every statement it should end with a semicolon. Here it had end with a colon. So we had violated the syntax of programming language. Hence this is an example for syntax error. Now coming to the runtime error. What do you mean by runtime error? Any error that occurred during runtime, we call them as runtime error. It will happen when you divide a number by 0. It will show you runtime error. Only this case you can see runtime error. Next is semantic error. What do you mean by semantic error? See, improper use of statement in a programming language can lead to semantic error. For example, now here I have written sum is equal to a plus b. That is, in your algorithm, I had taken 2 variables and I have calculated the variables and assigned that value to sum. Similarly, if you give sum is equal to a plus b, means the assignment is done from this part to here. You are assigning the values like this. So this is the proper use of programming statement. If you give it vice versa, that is a plus b is equal to sum, it is wrong. This is a semantic error. That is, you are using improper way of the programming statements. We call them semantic error. Example is the assignment. That is, if you give sum is equal to a plus b, value of a will be added with value of b and that final result will be assigned to sum. Here, sum is equal to a. There is no value for sum. How you can assign it to a plus b? So it is an improper use of statement. This is an example for semantic error. Last, logical error. What do you mean by logical error? When the concept is wrong, it is logical error, but your program runs even if you have logical error. Because see, sum is equal to a minus b. Suppose the value of a is equal to 10, value of b is equal to 5, A minus B. It is 10 minus 5, value 5 is assigned to sum. You will get the value. But whether the concept is proper, sum should be A plus B. You have to get 15, but you will get the answer 5. The program will be running, but the final answer won't be correct. Such errors are called as logical error. Now coming to the next step in problem solving methodology, documentation. What is documentation? When you give a note or when you prepare a note for your program, we call them as documentation. It is a reference material which will explain all the use of your program. It is of two types, that is internal documentation and external documentation. Once documentation is done, now you have to maintain your software or the program. How long you have to maintain? You have to maintain it till it is in use. So maintenance is a long stage. Till your software is in use, you have to maintain your software. So the updation will be there. It will be getting updated and it will be having modification based on the user's requirement. When the user requirement change, you have to keep on modifying it. This process we call them as maintenance. That is, maintenance is a process of continuous observation of the software to know whether it is capable to fulfill the need of user or user's requirement. So, till this, it's a steps involved in problem solving methodology. Now we can go to programming construct. Now let us see what does a programming construct mean. It means a statement in a program. So you have three types of construct: sequential construct, selection construct, iteration construct. First let us see sequential construct. What do you mean by sequential? It means the statements are executed one after another in a sequence. That is, it will have a particular sequence. Only in that sequence, that is one after the other, this statement will be executed. It is again of three types: input statement, assignment statement, output statement. Let's see each. What does it mean? In input statement, you will input the variable. As you had seen in the algorithm, I used to use input statement to input the variable which I use. So input statements are used to input the variable which we use in the program. Next, assignment statement. Assignment statements are done using equal operator, equal to operator. So if you are using assignment statement, definitely this operator will be present. Here A is equal to 10, B is equal to 5, A plus B, that is 10 plus 5, value 15. This value is assigned to C. This is what assignment means. We are giving the value to the variable. That's all. Now coming to the output statement. Of course, why outputs are used? That is to print. Here you will print the output, that is output C. It means it will print the value of C, that is 15. This is what sequential construct do. Sequential construct means it is executed one after the other. It is of three types: input, assignment, output. See, these are done one after the other. First you have to do input, then the assignment, then the output statement. They are executed in that manner. Now let us see selection construct. As I have told you regarding the branching statement in the previous chapter, this is concerned with it. That is, decision making statements or selection construct. Both are same. Here it is called branching. We are branching the program statement. Selection constructs are of 5 types: simple if else, if-else if, nested if, and multiple selection or switch. These are the different type of selection construct. Let's see each of it. First one, simple if. Simple if is the simplest form of if statement and it is called as one-way branching. The general form of simple if is if test condition statement 1, statement 2. Here one condition will be given. It will be checked first. If condition is true, then this statement will be executed. That is, statement 1 will be executed. Then statement 2 will be executed. If condition is false, then what happens? It won't execute statement 1. It will jump directly to statement 2. This is what simple if do. That is, it is one-way branching. The condition will be checked here. Condition is true, statement 1 will be executed. Then statement 2 will be executed. Or else, if the condition is false, it won't execute this statement. Jump directly to the statement 2. Let us see an example. See here, when amount is greater than or equal to 5,000. Suppose if I have 6,000 here, of course the condition is true. What it will do? It will do the discount amount. Then the net amount, the discount amount will be minus and you have to pay the net amount same. After deduction you will pay. But if the amount is less, suppose it is 300, then what it will do? Whether you are eligible for the discount? No, because it's just 300. So what happens it is, this statement won't be executed for this condition. The control will come directly here. The net amount will be calculated. You don't have any discount. That is, net amount is 300. You have to pay same. 300 minus 0. This is how simple if work. Now let us see if else. See, this is two-way branching. You had seen simple if is one-way branching. If else, it is two-way branching. Means you have options. That is, if A is greater than B, larger is equal to A. Or else, larger is equal to B. For simple if, you didn't have an else part. But in if else, you have an if part and else part. If condition is true, this part is executed. If condition is false, this part is executed. That is, larger is equal to B. For example, now I have 20, 50. Let A is equal to 20 and B is equal to 50. Whether 20 is greater than 50? No, my condition is false. So the larger value is, of course, it is B. That is 50. If I have A is 100 and B is 50, I'll check whether A is greater than B. That is, 100 is greater than 50. Yes, true. So larger is equal to A. That is, larger is equal to 100. This is how if else work. Now coming to the next construct, that is if else if. You had symbol if else. Now it is if else if. That is why it is called as else if ladder. That is the other name of if else if. This is multi-way branching. First one was one-way branching. Second one was two-way branching. This is multi-way branching. Just see the general form. If test condition statement 1. Else if, else. I'll explain with an example. See, if mark is greater than 60, the person is passed with first class. Else if mark is greater than or equal to 50 with second class. Or else if mark is greater than or equal to 35, it is third class. Otherwise, it is default. What do you mean by default? Fail. That is, here you have multi-way. That is the reason why it is called multi-way branching, because you have multi-way of options here. See, if the marks that comes greater than or equal to 60, it will be categorized here. Marks which is greater than or equal to 50, second option. Next, third option. Last, you have default option. That is the failed ones. This is the syntax of if-else if statement. In last, you have to give an else statement and then you have to give the default statement. If you write here else if default, it's wrong. You have to be very careful with the syntax. And this is called multi-way branching and it's also called as else if ladder. This is how else if ladder works. Multi-way branching. Now coming to nested if. What do you mean by nested if? If you place one if in another if statement, we call them as nested if. For example, see, I already have a if statement here. Inside this if statement, I am placing one more if statement. That is why it is called as nested if statement. When an if is placed inside another if, it is called as nested if statement. Example, if A is greater than B, if this condition is true, this will be executed and the output will be printed. Else it will come to the next control. And you have, for this if, you have an else if, then else. This is how nested if works. That is, when one if is placed inside another if, we call them as nested if. Now coming to the last selection construct, that is switch statement. In switch statement, you have multiple selection and it has a separate syntax which is different from if and its variants. See, you have switch expression, then open the brace, case label. Here you have to write case label statement 1 break. Case label statement 2 break. Till label end, you have to give break for each statement, because break if you give, the control will directly come out of this switch. That is why you give break. It will come out of the switch statement if you give break. So once this is executed, it is exited out of the switch statement. Let's see with an example. See, switch operator. Operator can be anything, plus, minus, asterisk, division or default. When I give default, it's a wrong entry. Suppose if I give something like this or like this symbol does not exist. So it's a wrong entry. Only arithmetic operator I am specifying here. So in switch operator, if any of this is encountered, what it will do it will operate that specific block. Now suppose my A is equal to 10, B is equal to 20. If I am giving the operator plus, my control come directly here. C is equal to A plus B, 10 plus 20. So C is equal to 30. It will immediately come out of this. That's what it happens. If it is minus, it will come here. It will execute 20 minus 10, 10. The value is 10. When break is encountered, it will directly come out of this. It's done. That is what switch means. Once when the break is encountered, it will come out of the statement. See how switch work. It is multiple selection statement. This is an example for switch. Now coming to the third construct, that is iterative construct or looping. What do you mean by loop? We call this as a loop. In programming, the loop will be continued until and unless the condition becomes false. So the loop will be exited only when the condition will become false. Otherwise what it will do? It will keep on looping. That is called as iterative construct or looping. Iterative statements are the statements that are used to repeatedly execute a set of statements until some condition is satisfied. That is, till the condition is true, the looping will be taking place. Otherwise, it will exit out of the loop. That is, when the condition is false, your looping is done. Now, you have two types of loop. Conditional loop, unconditional loop. What is conditional loop? See, in conditional loop, number of looping, that is how many times this loop will take place, it is not known in advance. That is why we call them as conditional loop. It is of two types, while and do while. Then what is an unconditional loop means? It means the number of looping or number of repetitions. It is known in advance. Example, for loop. Now let us see what is the conditional loops, that is while and do while, and then the for loop. See, this is a while loop and this is a do while loop, and this is the syntax. In syntax you can see while test condition, statement 1, statement 2, statement n. This is while, syntax of while statement. Here you can see do, statement 1, statement 2, statement n, and do while test condition. What is the difference between both? Here the test condition is checked initially. If the condition is true, then statement 1 is executed, statement 2 is executed, statement n is executed. How long it will continue? Unless and until this test condition becomes false. Unless and until the condition becomes false, this statement will be keep on executing. Now what happens here it is, initially the test condition is checked. If condition is false, then this statement are not executed. But when you see do while statement, you have statements first and then the condition is checked. When the condition is false, it will come out of the loop. If condition is true or false, however, these statements are executed at least once. That is the difference between while and do while. Because this is called as pre-tested loop. What is pre-tested loop? Condition is checked before executing statement. And here do while is post-tested loop. What does it mean? Condition is checked after executing the statement. That is why it is called as pre-tested loop and do while is called as post-tested loop. And this is the syntax. You can see it clearly in the syntax how the execution is taking place. The given condition is checked before executing the statement inside. See, condition will be checked first. Here, first the statements are executed, then the condition is checked. And here, first the statements are executed and at the last the condition is checked. So if the condition is wrong or it is right, the statement will be executed at least once in do while. There is a chance that the statement may not be executed even once in while loop, whereas here it is sure that statements are executed at least once. Why? Because condition is checked at the last. This is what while and do while loop consist of. This is pre-tested, this is post-tested. You have to learn the syntax, then you have to write how the execution will take place. That is, loop will be continued unless and until the condition is true. Once the condition is false, it will come out of the loop in both the case. This is what while and do while deals with. And these are looping structures. Loops are two types, conditional, unconditional. In conditional, you have while and do while. In conditional, you have while and do while. And in unconditional, you have for loop. What do you mean by a for loop? It is a fixed execution looping statement. Why we call them fixed execution looping statement? Because you know how many times the loop will be repeated. That's why I call them as unconditional loop. It is usually used when we know in advance the number of times that the statement needs to be repeated. Executing. That is, for execution, you know how many times your loop will be keep on repeating. That is, if you know in advance how many times your loop will be executed, you can use for loop. Let us see the syntax of for loop. For expression 1, expression 2, expression 3, statement 1, statement 2, statement n. So these are the syntax of for loop. In for loop, expression 1 represents initialization. What do you mean by initialization? Initialization means you are giving a value for a variable. For example, I is equal to 0. You can give even I is equal to 1. It means you are initializing the value. That's all. So the first expression counter is for initialization. Second one, to represent condition. That is, now I have given for I is equal to 0. I have to separate it with a semicolon. Then I am giving second expression, that is I less than or equal to 5. This is the second expression. What is the third expression? It is increment or decrement. Increment means I am incrementing the value by 1. Decrement means I am decreasing the value by 1. So I can give either any of this. If I give increment, I will give I plus plus. If I give decrement, I have to give I minus minus. This is the end of for loop. You can write increment or decrement. It means, that is, I plus plus means I is equal to I plus 1. That is what it means. So the first expression, initialization counter, you can give even I is equal to 1 depending upon the program. Then I am checking the condition. That is my test condition. I is less than or equal to 5. Then I am incrementing or decrementing the third expression. This is how for loop works. Initialization, initial value to the final value, statements, incrementing. Let's take an example. For example, if you want to print from 10 to 20, you have to print a number. So you have to initialize I is equal to 10. Why? Because you have to print the number from 10 to 20. So I is 10, I less than or equal to 20. So when I is 10, whether 10 is less than or equal to 20, yes, my condition is true. When the condition becomes true here, then this statement should be executed. It means you have to print the value of I. That is 10 will be printed. After printing the value, it will come to this section. That is the third expression, incrementing or decrementing the value. Here you have to increment because I is equal to I plus plus. So 10 value, I value is 10. Now I value will become plus 1. Now I value will become 11. Then what it will do? It will come and check the condition again. Whether 11 is less than or equal to 20, condition is true. Again it will print the value 11. It will increment. This process will continue when? Unless and until the condition is true. Now when the value becomes 20, even that will be executed. Even that value will be executed. Why? Because 20 is less than or equal to 20. The condition is true. Even the loop will be executed. Till 20 it will be printed. And once it will come to increment here, that is I becomes 21, you will check the condition whether 21 is less than or equal to 20. That time the condition becomes false and you will exit out of the loop. This is the end of for loop. I hope you understood the topics. That is, the chapter dealt with problem solving methodology. The process was there. Then we had seen programming construct. Programming construct, you have three types: sequential, selection, then last one iteration. And sequential, again it was divided into three types: input, output, assignment. Then we came to selection. In selection you had if statement, variants of if and switch statements. And it is decision making statement. All the selection statements were decision making statements. We have to decide whether we have to execute this part or this part. We had a choice, multiple choice, one choice, two choice, and all those things. Last we had looping. Looping means iteration. When we want to repeat a code continuously, we use looping. Advantage of looping is we need not write the code again and again. That is, when we know we want to repeat a code, we can use loop. Until the condition becomes true, it will be continuing. When the condition is false, it will exit out. This is what this chapter deals with. Hope you understood the topic well. Thank you.